All right. Okay. Here we'll talk about imaging from several um, optical components. For example, plane mirrors, spherical mirrors, and lenses. In this particular slide, we'll talk about particularly about images and plane mirrors. So before we go that, we will talk about few definitions which will be useful on all imaging from all components. Just like I said, plane mirrors, spherical mirrors, as well as the lenses. So object, whenever we say object, object is anything from which light rays radiate, and the objects can be self-luminous, for example a burning bulb, um, or lamp, or it can have an object that reflects rays from others. So I can have, like, we can see each other. We are not self-luminous, but when sunlight or room light is falling on us, that reflected light is falling on our eyes and we can see that, right? So an object, it can be self-luminous or reflected rays from other sources. We'll talk a point object. Point object means the size of the object is zero. There's no, so that's an idealized point object. So it's kind of like a point, right? So this is like, for example, this is my point object, right? So this is like a point. There's no size, no dimension to it. And extended objects are the real objects, right? Like tree, we, humans, objects, pen, paper, they're real objects. So they cannot be treated as a point object because it has finite size. Image point, I is an image point, right? That's where the image is formed. Object point, O is an object point. That's where the object is placed. Virtual image, virtual image, outgoing rays do not actually pass through the image point. So what is outgoing ray? So let's briefly talk here. This ray coming from the auxiliary point, that is called incoming ray. So let me write it. This is incoming, and this one is going outgoing, right? So outgoing rays do not actually pass through the image point. So this ray is not passing. This is my image point. It's not passing through image point. This seems like coming from the image point, right? So so if the image seems to be coming from there, then that's called virtual image. So here in this case, I is a virtual image. And real image, we'll talk, there will be several examples in ways can be formed on a surface. So if you have a screen surface or a screen, right? So if you put a screen here or here, we cannot image it. We cannot form this image because this image is a virtual image. So, so if you understand, great. But otherwise, we will talk in subsequent sections. We'll talk more of when we have a little more examples. So, all right. So sit tight till that time, right? All right. Okay. So we will talk about image formation by a plane mirror. So let's say this is my plane mirror. Right, so I'm showing this is my coated surface, this is polished surface, right? So this is my plane mirror, right? And I have an point object, so a point objects, and I denote it by letter O, right? All right, okay, so the ray is coming out of this point object, and this is shown here, and after incident on this mirror, it gets reflected. So following the law of reflection. So this is my normal. So if this angle is theta, this angle will also be theta. So if I put an eye here, this ray will seems like coming, if I extrapolate this here, this ray will seems like coming from here, and that we call it the image point, right? In the earlier slide, right? So that's one ray. Now let's say another ray comes here, and which is exactly falling normal to the mirror. What will happen? It will again follow the law of reflection. Since angle of incidence is 0, the angle of reflection should be 0. So it will go back, trace back. So if I look at this ray, particular ray, then it will seems like coming again from this point I, if I do. So when these two rays are extended backwards, then they meet at point I. And so this I is, we can call it, this is the virtual image I of object or point object, O, and this is my point object, right? So this one we can say point object O, point object. All right. Okay, so the perpendicular distance of point object from this meter, so this angle is 90 degree. So this distance we denote by letter P. So what is P? P is object distance. Okay, and this the perpendicular distance of the virtual image from the mirror. So again, this angle is 90 degrees. So this is called image distance I. So I is, let me write it here, I is image distance, right? So the I is the virtual image of the object or point object O, and the relationship between P and I is equal to negative P, because image is virtual. So this is there. So we'll talk about the sign convention in next slide, but at least for the time being, that's where, right? Image will be formed of the object O. So here we'll talk of some of the sign rules when an object distance or image distance is positive and or when it's negative, right? So let's talk about the first rule, about object distance. So object distance is positive when the object is on the same side of the reflecting or refracting surface, right, as the incoming light. So if I have this object here, right, so it's this object, let's say this is my object and I call it object O, then this is the same side of the incoming ray. So this ray is my incoming ray, right? Incoming ray. So my object distance will be positive, right? How about image distance? Image distance is positive when the image is on the same side of the reflecting surface. So here this will be something like coming from here, somewhere here, right? So image is not on the same side. So this image distance, which is behind the mirror, will be negative. So image distance is positive when the image is on the same side of the reflecting surface as the outgoing. Which one is outgoing? This is this one. This one is my outgoing light or outgoing ray, right? And we have not talked so far about the curved mirrors, right? So this is, of course, we are drawn here as curved mirror. We'll talk in next lecture that the rule of radius of curvature is ROC. We'll get used to these terminologies. This is called radius of curvature, right? And of course we are talking here about the curved mirror, not a plane mirror. So this is a curved mirror, right? So what's this the rule for the sign? The rules of radius of curvature of a spherical mirror or spherical surface: when the center of the curvature, let's say this side is center of curvature, is on the same side as the outgoing light, then it is positive, right? Or I may have another curved mirror. So let's say this is my curved mirror, but this side is polished, right? This side is polished. So if I have a ray coming here, let's say this similarly a ray coming here, what happens? This ray gets reflected in this direction. So that is something like it's coming from here. So in this case, it will be negative. So radius of curvature here will be negative. All right, we will cover this, particularly the rule C, in next when we talk about curved mirrors.